2 days ago, in the Pacific Ocean off the coast of San Diego, a capsule the size of a family SUV hit the water at 8:07 in the evening Eastern Time.
A new chapter of the exploration of our celestial neighbor is complete.
Inside were 4 people who had just done something no human being had done in 53 years. They had flown to the moon and come back alive. That capsule is now drying out on the deck of the USS John P. Murtha. The 4 astronauts are in Houston, being examined by flight surgeons. And somewhere inside the Vehicle Assembly Building at Kennedy Space Center, another rocket is already being stacked. Because here is the part almost no one is covering. Artemis II was not the finish line. It was the starting pistol. And what NASA is about to attempt in the next 24 months is either going to be remembered as the most audacious space campaign since Apollo, or it is going to collapse under its own weight on live television. Here is what actually happened on the way home. The 4 astronauts, Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, hit the upper atmosphere at Mach 33, that is roughly 25,000 miles per hour. For 6 minutes, plasma wrapped around the capsule at temperatures pushing 5,000 degrees Fahrenheit, and mission control lost all contact. When the communications blackout lifted, the parachutes opened exactly on schedule. The crew pulled almost 4 Gs of deceleration, splashed down 1,956 miles downrange from their entry point, and walked off the recovery helicopter on their own feet. By any reasonable engineering measure, it was a clean mission. Except for one thing. The heat shield came back damaged again. To understand why that matters, rewind to November 2022. During Artemis I, which flew without a crew, Orion's Avcoat heat shield came home with chunks of charred material missing, divots, cracks. The shield still did its job. Temperatures inside the capsule never breached design limits, but the damage pattern did not match the computer models NASA had spent years building. And when engineers cannot predict how a shield fails, they cannot guarantee how the next one will behave with 4 humans strapped behind it. For Artemis II, NASA changed the re-entry profile. They shortened the skip distance, the arc where the capsule bounces off the upper atmosphere before committing to final descent, to limit the time Orion spent in the specific temperature band that caused the damage. It worked. The crew is alive. But on Friday night, during the post-splashdown press conference, Orion program manager Howard Hugh confirmed what everyone in the room already suspected. The shield came back with divots, cracking, uneven ablation. The same fingerprints of the same problem, just less of it. Divers were photographing the damage within minutes of splashdown. Aircraft had tracked the fiery re-entry in real time to capture thermal data no simulation can replicate. NASA flew this mission knowing the shield would likely come home chewed up because they believed the underlying structure would hold, and it did. But a partial vindication is not a solution. The heat shield is also not the only open problem. During the mission debrief, managers listed a valve redesign required on Orion's service module and a toilet malfunction that sounds like a punchline until you remember 4 adults were sealed inside a capsule the size of a large SUV for 10 days with no window to open. None of this is catastrophic. All of it is unresolved. And all of it has to be resolved before the next crew flies, which, according to the schedule NASA confirmed this week, is 15 months from now. Here is where the story gets strange. For most of the last 5 years, Artemis III was supposed to be the big one, the return. 2 astronauts descending to the lunar South Pole aboard SpaceX's Starship human landing system, spending about a week collecting samples, the first boots on the moon since Gene Cernan climbed back into his lunar module on December 14, 1972. That plan is dead. In January of this year, NASA officially delayed Artemis II to no earlier than 2028. 5 weeks later, on February 27th, NASA Administrator Reid Wiseman reversed course and pulled Artemis III forward to mid-2027, but with a catch that almost nobody outside aerospace media registered. Artemis III is no longer going to the moon. Read that again. The mission that was supposed to be the return is now going to low Earth orbit. What the crew will actually do is this. 4 astronauts will launch aboard Orion on the Space Launch System. They will rendezvous and dock with one, possibly both, of the commercial lunar landers, SpaceX's Starship HLS and Blue Origin's Blue Moon, which will have launched separately on their own rockets. The astronauts will physically board the landers. They will test propulsion. They will evaluate life support. They will check the communications loops, and they will put on the new Axiom extravehicular suits that future moonwalkers will wear on the surface. It is, in effect, a dress rehearsal. The comparison NASA keeps reaching for is Apollo 9 from March 1969, when astronauts Jim McDivitt and Rusty Schweickart flew the lunar module in Earth orbit to test rendezvous, docking, and spacewalk gear, before Apollo 11 went for the moon 4 months later. Apollo 9 never gets the documentaries. Apollo 11 does. But without Apollo 9, there is no Apollo 11. What makes Artemis III nervous-making is the engineering behind it. SpaceX's Starship HLS does not just need to reach orbit, it needs to be refueled by at least 14 separate tanker flights launched from a propellant depot that SpaceX has not yet built, using orbital fuel transfer at a scale no one has ever demonstrated with crew-rated hardware. 14 tanker launches, 1 mission. A decade ago, that plan would have been dismissed as fan fiction. Blue Origin's Blue Moon lander is smaller, more conventional in design, but equally unproven. Neither vehicle has ever flown with a human inside. A March report from NASA's own Office of the Inspector General flagged the uncomfortable truth that the uncrewed demonstration landings now required before certification will not fully match the crewed configurations, which means the first time either of these landers carries an astronaut in its final operational build might be the actual mission. If neither company is ready in time, Artemis III has a problem. An Orion flight without a lander to rendezvous with is not Artemis III, it is just another orbital mission with a more expensive rocket. Now here is where I want to address something directly, because every time this channel covers NASA, the comment section splits cleanly in two. Half of you write in saying Artemis is a trillion-dollar vanity project and we should have sent robots instead. The other half say we are being too pessimistic, that Apollo faced worse odds and still pulled it off. Both of those takes are missing the actual story. What Artemis has become, whether NASA wants to admit it or not, is no longer a government space program in the traditional sense. It is a risk transfer program. The hardest parts, the lander, the orbital refueling, the suits, the surface rover, have all been pushed onto private companies. NASA is now the customer, not the builder. And that changes what failure looks like. When Apollo 1 burned, Congress stepped in. When SpaceX loses a Starship on ascent, the market moves on by Tuesday. Whether that is progress or a quiet abdication depends on what happens in the next 24 months. Keep watching, because that is the real test. Assuming Artemis III works, everything pivots to Artemis IV, early 2028, the first crewed lunar landing in 56 years. 4 astronauts launch on SLS and Orion. They fly to lunar orbit. A commercial lander, either Starship HLS or Blue Moon, is already waiting in an elliptical polar orbit, dipping to about 62 miles above the surface. Orion docks. 2 astronauts transfer across. They descend, and for the first time since the last Apollo crew left their footprints in the Sea of Serenity, human boots press into lunar regolith. The landing zone is nothing like Apollo's. The Apollo missions landed on flat equatorial plains under constant sunlight, which is essentially the easiest lunar terrain there is. Artemis IV is targeting the South Polar region, a place that no human and only a handful of robotic probes have ever surveyed, and it is a genuinely alien environment. At the South Pole, there are craters whose floors have not seen sunlight in billions of years. Inside those permanently shadowed regions, temperatures drop to -390 degrees Fahrenheit, cold enough to freeze carbon dioxide solid. And trapped in that cold, according to data from NASA's Lunar Reconnaissance Orbiter, is water ice, possibly a lot of it, possibly delivered by comets long before life existed on Earth. If you could stand on the rim of one of those craters and look down, you would see absolute black. No atmosphere to scatter light, no reflected glow, just a void cut into the surface of the moon. That ice is why NASA picked this region and nowhere else. Water splits into hydrogen and oxygen. Oxygen means breathable air. Hydrogen and oxygen together, when recombined correctly, mean rocket fuel. The South Pole is not just a science destination, it is a potential filling station for everything humanity might attempt beyond the moon. NASA has identified 9 candidate landing zones in the polar region, each containing multiple specific sites. The final call depends on which lander flies and what its descent capabilities will allow. Some sites give better access to the shadowed ice, others offer more reliable sunlight for solar power. None of them resemble the postcard flat terrain Neil Armstrong touched down on. The crew will stay about 1 week. For context, the longest Apollo surface stay was 3 days. They will conduct at least 2 spacewalks in the Axiom suits that were tested on Artemis III. They will deploy a seismometer called the Lunar Environment Monitoring Station, designed to listen to the moon's internal vibrations, the way geologists listen to earthquakes on Earth. They will collect samples from terrain no human has ever touched. Then they will ride the lander back up, dock with Orion, and come home. The full mission runs about 30 days. Artemis V is where the language changes. NASA stops using the word mission and starts using the word base. Targeted for late 2028, just months after Artemis IV, this one sends 2 astronauts down on Blue Origin's Blue Moon lander. For the first time since Apollo 17, they will drive. A new lunar terrain vehicle designed for the polar environment and pre-positioned on the surface by an earlier robotic cargo delivery will let them cover more ground in a single week than any Apollo crew managed in 3 days. But the real purpose of Artemis V is construction. This is the mission where NASA expects to begin physically assembling a permanent outpost, power generation arrays, communication relays, mobility platforms, delivered to the surface by uncrewed cargo landers under the Commercial Lunar Payload Services program, then activated and connected by the Artemis V crew. Administrator Isaacman has described this as Phase 1 of a 3-phase plan: build, test, learn. Phase 2 adds semi-habitable structures, shelters, and workstations. Phase 3 is continuous human presence, crews rotating through every 6 months, living and working on the moon the way astronauts currently live and work on the International Space Station. The target date for continuous lunar habitation is 2032. To keep the lights on during the 14-day lunar night, when solar panels are useless, NASA is developing a surface nuclear reactor, small enough to fit in a compact car and roughly 10,000 times less powerful than a terrestrial power plant, but steady. Meanwhile, the Lunar Gateway, the orbiting station near the moon that NASA had been planning for years, was formally canceled in March of this year. The money and the engineering talent have been redirected to the surface. The focus is dirt, not orbit.